Thousands of years ago, without a single piece of modern technology, humans accurately charted the heavens. This is the complete foundation of ancient astronomy, the earliest and most vital scientific endeavor in human history. And what these ancient stargazers accomplished with nothing more than their eyes, sticks in the ground, and an obsessive need to understand the cosmos above them is frankly staggering. They measured the Earth to within 2% accuracy. They predicted eclipses decades in advance. They built computers out of bronze gears. And they did all of it millennia before anyone had a telescope. Astronomy is the oldest natural science, not chemistry, not physics, not biology, astronomy. It was the first discipline to reach a high level of sophistication and predictive ability, achieving that milestone already in the second half of the first millennium BCE. And the reason is beautifully simple. The subject matter was stable. The sun, the moon, the planets, the stars, they moved in complex patterns, yes, but with great underlying regularity. The sky was a puzzle that repeated itself, and human beings couldn't resist solving it. Modern astronomy is part of a continuous tradition now almost 4,000 years old, cutting across cultures and languages. And that tradition didn't begin with wonder. It began with need. The earliest astronomers weren't scientists. They were closer to priests. Patterns in the skies were watched and recorded to make predictions about daily life, crop failure or success, and the favor or displeasure of the gods. In China, evidence of sky observation predates written records entirely. Neolithic pottery from over 5,000 years ago is adorned with images of the sun. Archaeologists have discovered carved shells and animal bones depicting stars and supernovae that may date back to 1400 BCE. During the Shang dynasty, from roughly 1600 to 1050 BCE, notes of eclipses were scratched onto oracle bones and tortoise shells. But it was in Mesopotamia, in the river valleys of modern-day Iraq, where ancient astronomy took its first giant leap toward becoming a true science. Around 2000 BCE, the Babylonians began the first recorded systematic study of the stars. By roughly 1200 BCE, they had produced the Emul-Apin tablets, a comprehensive sourcebook of star locations, astronomical descriptions, and star appearance schemes. And here's something most people don't realize. Every time you glance at a clock, you're using Babylonian math. They developed the 12 signs of the zodiac. They divided the circle into 360 degrees. The division of the hour into 60 minutes and a minute into 60 seconds comes directly from their base 60 number system. That system is over 3,000 years old, and we still use it every single day. By the 5th century BCE, the Babylonians had developed the earliest known form of mathematical astronomy in the ancient world. Their anonymous scholars working at places like the Resh Temple in Uruk weren't just recording what they saw, they were calculating. They could predict the positions and timing of special planetary phases, and their methods were revolutionary. Researcher Mathieu Ossendriver discovered that these Babylonian astronomers were using geometric techniques, specifically trapezoid calculations, not to measure fields or gardens, but to track the motion of Jupiter through abstract mathematical space, plotting velocity against time. As Ossendriver put it, they are applying it to astronomy in a totally new way. The trapezoid figure describes an object in mathematical space. This is a concept we consider modern. They were doing it over 2,000 years ago. Alexander Jones, professor of history of exact sciences at New York University, described one key tablet as testimony to the revolutionary brilliance of the unknown Mesopotamian scholars who constructed Babylonian mathematical astronomy. And the consequences of getting predictions wrong were very real. There's a documented case of a Babylonian astronomer who was arrested for incorrectly predicting an eclipse, causing people to perform an elaborate and expensive ritual that turned out to be unnecessary. Meanwhile, halfway around the world, the ancient Greeks were transforming astronomy from a practical tool into a philosophical quest. Around 400 BCE, Greek thinkers began seriously investigating planetary motion, and they produced some extraordinary minds. Aristarchus of Samos, living around 310 to 230 BCE, proposed something radical. He said the Earth rotates on its axis and revolves around the Sun, a heliocentric model, 18 centuries before Copernicus. The philosopher Cleanthes declared that Aristarchus should be indicted for impiety, for putting into motion the hearth of the universe. His idea was rejected. People couldn't accept it because they couldn't explain why the stars' positions appeared constant despite Earth's supposed movement. It would take nearly 2,000 years for his insight to be vindicated. Then came Eratosthenes on June 19th. 240 BCE, this Greek scholar completed his calculation of Earth's circumference. His method was elegant. He knew that at noon on the summer solstice, the sun cast no shadow in Syene, modern-day Aswan, but in Alexandria, it did. He measured that angle, then hired bematists, professional distance measurers trained to walk with a perfectly even pace, to determine the distance between the two cities. His result? Approximately 25,000 miles. The actual circumference is 24,900 miles. He was accurate to within about 2%, using nothing but a stick, geometry, and men who could walk in a straight line. Hipparchus pushed even further. In 134 BCE, observing from the island of Rhodes, he spotted something no one had seen before: a new star. Some of his contemporaries considered cataloging the stars to be an act of impiety, but he persevered. By 129 BCE, he had compiled the world's first reliable star catalog, documenting approximately 850 stars and establishing the magnitude system we still reference today. He measured the length of the solar year to within 6 minutes and 14 seconds. And he discovered precession, the slow wobble of Earth's axis through a cycle lasting about 25,772 years. His estimate of at least 1 degree per century was a remarkably good first approximation. Across the Atlantic, the Maya were building their own astronomical tradition. Between roughly 250 and 900 CE, they developed an extraordinarily complex calendar based on meticulous observation. Archaeologists discovered a small room where royal scribes used walls like blackboards to track astronomical records. These walls contain the oldest known astronomical tables from the Maya, and their calendar system projected vast cycles of time stretching millions of years into the future. As Anthony Aveni of Colgate University noted, why would they go into those numbers if the world is going to come to an end? A number that big at least suggests that time marches on. And then there is the Antikythera mechanism. Pulled from a shipwreck off a Greek island, this device dates to roughly 150 to 100 BCE. It consists of at least 30 interlocking bronze gears housed in a wooden case about the size of a shoebox. It could track the movements of the sun, moon, and all 5 planets known at the time. It predicted lunar and solar eclipses. It even tracked the cycle of the ancient Olympic Games. It combined Babylonian astronomical cycles, mathematics from Plato's Academy, and Greek astronomical theory into a single portable device. A 2025 study revealed that it actually jammed frequently, able to crank only about 4 months into the future before its gears disengaged, much like a modern printer. But even with that limitation, its existence 2,000 years ago is almost incomprehensible. The Great Pyramid of Giza, built some 4,500 years ago, is aligned to true north with an error of just 3.4 arc minutes. That's a precision of about 1 millimeter per meter. And the pyramids are so ancient that even Cleopatra considered them ruins. Ancient astronomy gave us our units of time, our maps of the sky, our understanding of Earth's shape and size, and the very concept of using observation and calculation to understand the natural world. The method these astronomers pioneered, watching carefully, recording precisely, and computing rigorously, is what we now call the scientific method. The birth of ancient astronomy was, in every meaningful sense, the birth of modern science itself.